This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 132, an update on Ansys additive tools and a look at news and events in the world of Ansys. Welcome to this latest episode of our little podcast. We've got a great interview for you coming up and a look at Ansys's really good Q3 numbers. This should come out before we celebrate Thanksgiving here in the US, and I want to take a little time to thank all of our listeners, you, for being part of these 132 episodes. And a huge thank you to our staff here at PADT, especially Trevor Rubinoff, who does a lot of the behind-the-scenes things to make this podcast happen. We really do enjoy sharing our knowledge and having these discussions. And we say it a lot, but never enough. We're thankful to be part of the world of Ansys. Events and such are winding down here in the Western U.S. I'm recording this on the 13th of November. And when I'm done, I'll head up north part of Phoenix to the Arizona Technology Council's Governor's Celebration of Innovation, which is our largest and last major event of the year. It's been a pretty significant year for manufacturing innovation in the state of Arizona, as well as across the country and around the world. And a lot of that has been around artificial intelligence. So we're not ignoring that here at PADT. We're using it in a lot of different ways, and we're working very closely and watching very closely as to what Ansys is doing. So no promises, but we're working on getting some people from Ansys to join us to share what they've done and where their vision is for the future. So stay tuned for that. Hopefully we'll have a good bit of information to share on that next year. And speaking of trends, a few years back, the big thing in simulation was modeling the behavior of metal 3D printers. And if you remember, PADT does do a lot of 3D printing, so it was a really nice matchup for us. Well, now, here at the end of 2024, that technology is fairly commonplace. It's used a lot. And we thought it would be a good time to sit down with experts from Ansys and PADT to get an update on where things are. So we did just that. Enjoy. Welcome, everybody, to another discussion today about Ansys, using Ansys with other things. And today we're going to be talking about using the Ansys additive products to help us do additive manufacturing, but specifically metal 3D printing. Many people may not be aware, but PADT is a reseller of EOS metal additive technologies. So we get our feet wet in both the world of simulation and the world of metal additive. And so we always like to talk about the two when we get a chance to combine the two. So that's what we're going to do. And we are fortunately joined today by an expert from EOS Technology, Vincenzo. Welcome to our podcast. Why don't you start us off by just talking about yourself and what you do at EOS?
Hi, everyone. Welcome to the podcast. I am Vincenzo. It's great to be here. Thanks a lot for inviting me. I'm Vincenzo Abbatiello. I am at EOS now since 2018. My background is aerospace engineering. I got a bachelor's and master's degrees in aerospace engineering in Italy. And since 2018, I landed at EOS, where I am in the Additive Minds department. Additive Minds, basically, it's a group of engineers within my company, EOS, where we support basically our customers in their journey towards additive manufacturing. And mostly, I am responsible for design for AM and any kind of simulation that is related to additive manufacturing. That can be from a standard FEM linear calculation down to some crash analysis, or going to topology optimization, generative design, or anything related, for example, also like process simulation. That is nowadays, in my opinion, really, really important in the laser powder bed fusion field.
Great. Excellent. Very good. Well, we appreciate you taking the time and joining us. Christian from PADT, why don't you introduce yourself?
Yes. Yeah. My name is Christian Crowley. I'm an application engineer here at PADT on the structural side. So, as you know, our business, we resell Ansys. And so part of my job is to help our customers evaluate whether or not Ansys, specifically the Ansys tools, can be a benefit to their organization. Beyond that, I also help companies that have bought the tools from us to learn the tools better, to show them how to use them, help any support questions come along the way. And as that happens, I become more and more expert on all these tools, including the additive suite processes. So whether that's topology optimization, whether it's actually simulating the build process, I've been on customer calls where we've helped evaluate those tools and also helped customers actually use those tools in their own production.
Cool. Very good. And Doug?
Yeah. I love it when you catch me like mid typing something. So I pretend like I was paying attention the entire time. Yeah, my name is Doug Oatis. I'm a PADT. I usually say it's a non-continuous 20 years.
Mm-hmm.
But that seems low actually. So I don't remember how long I've been here. A while. It's been non-continuous. And yeah, I'm just a mechanical engineer. But using Ansys since 2003. So back in pre 64-bit days. So
Yes.
So yeah, I mean historically structural mechanic guy, but pretty much anything from structural thermal, all that stuff. But kind of into my elder role now, I guess I'm a manager of application engineers, and so Christian reports up through me, and so I don't get as much kind of daily use, I guess, but still seeing the use cases and working with a lot of our larger companies on the applications, and kind of been at the, I don't want to say forefront, but using the additive suite for quite a while, trying to remember the alphabet soup of all the different acronyms and different names of the Ansys products as they kind of mature and become easier to use.
Yeah, true. And I'll point out now that if listeners want to get a little bit more history on that, they can go back and listen to some of the early podcasts when Doug and I talked about how things were getting started with Ansys Additive about 3 or 4 years ago. So cool stuff. Well, Vincenzo, let's go back to you and talk a little bit more, if you can, about EOS. It's a German company. I believe it's the leader in metal additive. Can you just share a little bit for our listeners that may not be familiar with the company, what you guys do?
I mean, first of all, let's let's stay humble. I mean, I don't want to say that we are the leader, but I mean, we are putting a lot of effort to develop and deliver a really great product to our customers. EOS, yes, you're right. It's a German-based company, but we are worldwide. I mean, that also in the US, we have 2 or 3 offices in the US, North America in particular. So EOS, it's a company that actually it's 35 years old this year. Yeah, it's turned 35 years old. It was established by Dr. Langer in 1989. Started from a technology as a sort of rapid prototyping. In fact, our first customer was a big car manufacturer here in Munich. I will not do any name, but I mean, you can surely understand.
Yes.
Where I heard the story about it, where everything started to produce a block, an engine block, starting doing by casting, but the casting fixture was then additively manufactured, starting by additively manufacturing the sand. And this was, let's say, a really breakthrough that Dr. Langer basically started to receive order by also other kind of industries and so on. And then the additive technology, starting from this let's say, relatively little, it was a big one, that actually started from a Hoover from the kitchen, from an appliance from the kitchen. Actually, that was the first building chamber. Moved to, let's say, this big machinery that we are doing today. As I mentioned, our company is 35 years old, established in 1989. Nowadays counts around about 2,400 employees worldwide. We have 2 main technology. One is SLS, it's the selective laser sintering, mostly related to polymers or any kind of, mostly to plastics, let's say like this. And then the laser powder bed diffusion, LPBF. I am mostly a metal guy, let's say like this, not only by music, but also by technology. And really like this technology. We have several machines, several customers worldwide that we serve. And we have roundabout installed 4,500 or maybe even more systems worldwide. Let's say the ratio is roundabout 50% metal, 50% polymer. And our machinery, mostly industrial machineries, basically machine that you can use to have an industrial production. I mean, you can see basically all these new rockets that they are flying in the space, or spare parts for aircraft engine, medical industry. One of our biggest market is the medical environment. Most of the parts that are used, for example, for surgery, and so on, mostly they are printed with our system in several materials, like for example titanium. And considering that we have a very big market, very big customers, and our goal is basically to make this technology accessible as a wide audience as possible, we established a few years ago this group of engineers called Additive Minds, where I belong. That it's, let's say, a way to educate our customers, not only to use the machine, but how basically to exploit most of it, to exploit most of the technology to get the best of it. Because our interest is basically to make the customer successful, so that basically we can sell even more systems. That's our goal.
Great. Yeah, that's a really long journey, and I think a lot of people don't realize how long companies like EOS have been around. It's been great to see it grow and prosper over the time, and to be part of that family. But let's talk about simulation. So we'll talk. Let's start with design for additive, which I think is an important role for simulation. But before we get into talking about modeling the actual manufacturing process, I don't know, Christian or Doug, where are we with topological optimization in the Ansys world right now? It seems like we got a couple of tools. It works in a couple different ways. What are your thoughts on topological optimization these days? And I bring it up because the only way to make the geometry you create with topological optimization is often additive.
You got to call it structural optimization.
Thank you. Yes.
Because topological is only one of the methodologies.
True.
And so, topological optimization, that's the, whittling away at material. Then you have the shape optimization, which is kind of pulling and poking, stretching node elements. Then you have, you have lattice optimization, which is a whole other way of thinking of, realizing that, there is no spoon and the inside of your part doesn't have to be solid, right? that kind of thinking process. It's gone from an immature tool set, back in the version 15 days. And so, there's, ultimately any type of optimization is going to be limited by the amount of simulation environments that feed it, right? It's it's as well as you can characterize the loading. If you can't account for all the different ways your part's going to be used, then the optimization is really more of a guide rather than an absolute. And so fairly well established. Lots of manufacturing constraints, lots of different simulations. Whether it's gravity, thermal load, multiple load cases, nonlinear, all that kind of stuff can feed into what drives that output, and then ultimately it's all about how clean can you generate an STL that can be then fed into a process that can generate all of your slices in order to create your scan file, your scan pattern.
Cool. So Vincenzo, are you seeing customers out there using more topological for real? We've been playing with it for a long time, and we all have kind of cool objects somewhere on our desk that we 3D printed after some topological optimization. But are you seeing customers use it out there for real world parts?
Yes, I can tell you, yes. Unfortunately, I cannot disclose so much like names and so on. That's for sure.
Specifically who.
But I can definitely tell you that it's exploding a lot. There was just a problem that in the past, this technology was marketed like the holy grail of the manufacturing techniques. And this, in my opinion, got, let's say, a lot of sales back in time. But nowadays, I strongly believe that everything is suffering a bit, all from a hardware and also from a software point of view. But nowadays, there's been a lot of development from Ansys, from other kind of software developers. Let's say there is even more potential and more possibility to create objects that are, let's say, with high performances and more feasible to be manufactured. I can guarantee you that there are customers that are using, for example, topology optimization to design their component for their car. Like, for example, a few days ago, there is an Italian car manufacturer. They also, without doing the name, but they produce red cars. I think that all of you know which one. They released a new car, and you can see in the picture of this new car that there is a 3D printed parts realized with topology optimization. In my opinion, this is a great achievement, but also other customers, they are running, aerospace customers, they are running, have a lot of brackets, some public, like Airbus, Boeing, they have a lot of parts, not really critical structural components, but they have a lot of parts that are coming out from a generative design approach that could be shape optimization, topology optimization, or any other kind of approach.
Cool. I'm glad to see that. I think it's pretty exciting and can really have some significant benefits that we've been hoping for many years now. So staying though pre-process, let's talk a little bit about again, maybe Christian, you can address this, using simulation to model your parts before you build them. Is there anything special you think users should do, or is it pretty much just a standard process? Once you get your geometry, you just do your normal simulation?
Yeah, I feel like every time I go and read the documentation for our, basically I'll call it our additive print simulation, like actually simulating the print process, I learned about a new technique that Ansys has in there. And some of that's because they're going between interfaces, going from a standalone interface to being put into the mechanical interface itself, which is Ansys's FEA structural solver. And as they do that, they're kind of refining the techniques as well. So what I actually was learning about recently is, we can import like EOS build files or other printers as well, but it's definitely the EOS ones. And we can actually, take into account the hatch scan patterns of the laser.
Okay.
So like, I know this is kind of like a tangent, but to answer the question, like, you can get as general as I put in the melting point of my metal and its geometry and get results, or you can get as specific as I want to actually simulate like the individual scan lines. And I think even mechanical now, to do that, they actually have like an AI learning model behind the scenes that's adapting how those scan lines are translating to the part. But the main way I usually see people do it is they use the built-in distortion compensation toolbox that we have in mechanical. So you simulate your part, you start with the geometry that you want it to look like, simulate the part, see what it deforms to, and we can actually, basically do some vector operations on your ideal CAD to get it into a pre-deformed state, so that we can now print that part, and so it will nicely deform into what we actually want to build.
And so that's a really good point that I think over time we've kind of forgot, at least I forgot about quite a bit, is this additive process of building a part by basically melting one layer at a time and resolidifying causes residual stresses from the cooling. And those residual stresses can cause distortion as well as actual failures in the part. So correct me if I'm wrong, but what we're talking about here is kind of calculating what do those distortions look like, and then compensating for them so that when you build it, you end up with the net shape that you're looking for. Is that what you're talking about here?
Yeah, that's exactly correct. Okay. Yeah, and we can even go on further to like actually simulate like maybe your heat treatment process at the end too, so that we're counting for the entire build process of this part.
Okay, yeah. So there's a lot there. So back to Vincenzo, are you seeing more of your customers adopt simulation as part of getting their process better, getting better quality parts? I mean, what are you seeing out there as far as people adopting simulation in metal additive?
let's say like this, you are in the business as well. So whenever you propose simulation to a customer and they have no clue about what is simulation, they consider it just something like that it's nice to have, but it will be not the solution to their problem. But whenever you show them that applying simulation and applying a pre-compensation, they will achieve their tolerances, I mean, they definitely change their mind. I mean, I know some people that some companies, even experienced customers of EOS with a machine since 10 years, that they were not even able to print a component that very crazy distortions, not even able to achieve the tolerances that they were supposed to have. And this basically was, let's say, a bottleneck to their production. They came to us. We enabled a bit of design for AM, like changing some details on the part, adapting some lower angle, reinforcing the structure where it was needed. And then after that, on top of it, we simulated the part, pre-compensated. And then at the first shot, we, after 1 month, basically, we had for them the final product that they were working for 2 years without getting any good results. And they were so astonished that they started their production, they purchased the software, they purchased a new machine because the production gets so big, gets faster and faster. And in my opinion, if you can show to the customer with a tangible results that really the simulation makes sense, that in my opinion makes sense. Nowadays, honestly, any kind of project that I run for customers, I run always including a simulation. I never print anything before that I've simulated, not only for pure manufacturing, but also during the design, during the development process, just to understand, for example, how the part is behaving during the printing process and see if I can improve it from a design point of view. So I will have, let's say, more benefits afterwards, like less supports, less post-processing, so less cost in the end for the customer. In my opinion, simulation, it's a really good investment, a perfect investment for additive manufacturing.
Very cool. Very cool. I'm glad to see that taking shape and people adopting it. And I always remember one of the first times we visited one of our customers that we were working with on the polymer side, but they had some metal machines. They had this giant bin full of broken parts. And you're like, considered using simulation. So cool. I love to hear that. So Doug or Christian, why don't you give us kind of a quick overview of what the different modules are? As you mentioned, you kind of alluded to it. The names and locations of the different tools are merging as they put these tools inside the mechanical platform. But what are the modules available now for people interested in modeling their additive process?
As I was thinking about this, and what was like the process, like what was the rule where like the number of transistors on a chip had to keep doubling every like there's a certain law that says like this is how technology should proceed. And hearing Christian talk about running through these distortion compensation, and like it almost makes me mad because like that used to be really tedious.
Yeah.
And so it's the law of simulation is as each rev comes out, it should get easier to do.
Yes.
Right. Like you shouldn't need to maintain one person that this is their sole responsibility. It should become a bit easier. And so but part of that is alphabet soup of products and stuff like that. And so, ignoring the history of, APDL to Workbench, 3D Sim offerings, integration within the Ansys environment, you can either tackle this through, and speaking purely from, the additive side, not creating the part that needs to be printed, right? And so, you have what's available within the Workbench environment. So I'll call that Workbench additive. It's probably the wrong term, but it's everything housed within Workbench, and so that that'll cover your powder bed fusion, your direct energy deposition, sintering, and all of that. Really has the entire process of print, heat treat, cut off, distortion compensation, all of that for those processes. And all grossly simplified as ultimately it's a massive thermal distortion problem that you need to account for, either by making sure that material doesn't get too hot, that it's properly supported, that the cooling works, or that the heat treatment or post treatment works properly. And so that's what's available on the workbench side. You have a whole Ansys additive kind of outside the workbench environment. So if you're not an FEA user, you're just running the machine, you want to see whether or not your machine will break, your part survives the print, that kind of stuff. There's an Ansys additive that is fairly straightforward, definitely a different interface. Like I said, you don't have to necessarily worry about mesh settings and stuff like that. It's all voxel based. Not to say that voxel isn't available within Workbench, because that's a lot of cross pollination there. And the other thing to talk about is we have this whole Granta side of things. That sounds like very insulting to Granta, because people think of it as just a material library, but really Granta gives you the ability to track your own process. And so if I'm looking at which lot of powder I'm using, which machines I'm using, which work shift is running the machine, how I'm post processing, and I'm also doing material testing off of finish, some type of mechanical property like ultimate tensile strength or anything like that. Really that's a whole bunch of data, right? And so Granta stores that, and now we can use AI, ML, or pick your favorite 2-letter acronym.
Yes,
sifting through big data, and we can use tools in order to figure out if I have a goal of a particular output, this is how I should be running my process.
That's really, so that's a major area that people really need to be aware of is this integration of Granta into that. That's really cool.
It's one of these, like, if you're not keeping copious notes of your process in order to make it better the next time, like, that's kind of the challenging question is like, all right, well, you did this one time, what are you going to do to make it better the next time? Like, so that should be the goal.
Cool. That's really cool. So there's a lot there. Vincenzo, I think we're gonna wrap it up a little bit here. Wrap it up a little bit here. Is there any words of wisdom? Let's just imagine you've got a new EOS customer. They got their machine up and running. They've done the test parts. What advice would you give them around simulation to make them more successful?
As I mentioned before, most important thing is to show basically the tangible, the tangible proof that the simulation works. But the most important thing is that to be afraid. Some before you mentioned that you have been visiting the customer, checking a bucket or a box full of scrap parts.
Yep.
I can strongly confirm that the use of simulation will reduce this box of scrap parts as crazy. And then honestly, with the cost of the material, machine per hour and so on.
True.
It's still cost that the company in the end is sustaining. I strongly believe that investing in a software, in a simulation software, like can be an Ansys software or any solution, I strongly believe that this box filled with scrap parts will be reduced drastically, and this is all benefits. In the end, the software will be paid by itself, reducing the scrap rate. That's what I can confirm. And then it's not magic what is happening. It's just math. Once it's properly calibrated, the software, for sure you will get great results.
Very cool. Very cool. We obviously agree with you on that one, and have seen it come true over and over again. And I think on the manufacturing side of things, the mentality has been build and bust, and it's taken a little bit longer to prove the functionality here. But with time, I think everybody's kind of seen by now those pictures of the SpaceX engines, the original design down to the current design. It's much more simplified, and we're not involved in that, and I don't know the details. but I bet you there's a lot of simulation that went into getting that design simplified. And those are also made with metal additive manufacturing. So I'm sure that's part of it.
I believe it too. Yeah, I believe it too. I want to add something also to finish. This is basically mostly a recommendation from for, let's say, software vendors, also for Ansys, but we are in a partnership with Ansys. I mean, I'm working a lot with them. Best would be to have, let's say, software that are, let's say, simplified simply as possible, that can be run from anyone, because most of the time production facilities with machines, they are operated from people that they have no clue about FEA. So it would be, in my opinion, better to make, let's say, even if I'm saying these words, I'm saying because I'm a fanatic about FEA. I am really love to go deeper in the mesh, to move even manually the nodes of the mesh. I'm fanatic about this topic, but I strongly believe that the industry needs more sort of easygoing solution, plug and play solution with just hit a button and then you get the results. This is the way, like this, let's say, software, in my opinion, can be expanded. The market for the software can be expanded more and more towards, let's say, users that they are not really experienced with FEA.
I 100% agree. 100% agree. Christian or Doug, do you have any parting thoughts on this topic?
I just wanted to say that Vincenzo mentioned calibration, and I don't, as far as getting rid of that fear of if, will the simulation work? Can we do this? Like, build test parts and then simulate that test part. Not a huge investment to compared to your probably production parts to make these test geometries. And Ansys has built-in workflows talking about plug and play solutions for essentially running optimization behind the scenes to basically calibrate your simulation to whatever you need to match your printer's build parameters. Just to be clear, we can have tons of parameter inputs and options, etc. inside of Ansys, but we're never going to be able to account for every single environmental factor. And so that's why calibration is always an important thing. Like, if your material changes, that there's going to be parts of that we need to re-account for. So always do calibration. Could be fun. And Ansys has some great tools for just basically hit a button and it will figure out that calibration constants for you.
Big improvement there. Doug?
Yeah, I think so. This isn't necessarily simulation based, right? A comment, but I think what a lot of people normally forget or ignore when they if you're switching or you're introducing additive into your system, like if you're taking a part that you're casting, forging, whatever process, and you're just trying to print it, you're doing it wrong, right? Like this is amazing. This is almost infinite number of possibilities of how to create a part, and all you're doing is changing your manufacturing method. You've missed the boat. You've missed the benefit, because really what you should be doing with additive is your part count should be going down by multiple factors. And so if you're new to this, and in addition to running simulations to figure out what your part should look like and whether or not it'll survive the print process, or if there's ways to improve your survivability or throughput, as soon as you're looking at additive, you should be combining parts. That's if you're not working with a partner who has done that in the past, you're not realizing the entire game from the additive process.
Very good point. Yeah, don't just take your existing parts and print them.
Yeah, like you can, but I mean, that's
there's not a lot of value there.
Yeah.
Yeah, gotcha. Agreed. Well, we could talk about this for a very, very long time, but we'll have to wrap it up. I really want to express my thanks for all of you joining me, Vincenzo, especially you joining us from overseas, and always good to have Christian and Doug on the podcast. And thanks a lot. Hopefully, users can learn a lot, and if they have any questions, they can certainly reach out to PADT. We can talk about the EOS side and the Ansys side. So we're more than happy to answer those questions. But thanks, guys.
Thank you.
Thanks to you.
Thanks. I'll talk soon. Bye.
Bye.
A lot of material covered here, but as you can see, these tools are practical and part of the process for many users of metal additive. And so we just want to get rid of those big big bins of broken parts. So please do reach out if you want to learn more. We'd love to talk to you about it and share our experience in this area. So for this episode's commercial, I'm going to switch gears a bit and talk about startups. It's not something I talk about a lot on the podcast, but they're kind of a passion of mine. PADT does angel investing, and also I also officially mentor startups through the Arizona Commerce Authority and an organization called the Clean Tech Open. I'm also available for unofficial discussions and specialize in helping technical founders navigate the investing and small business worlds. So really helping kind of those technical people get their feet wet in this world of startups. And another way that PADT supports the startup world is through the Ansys Startup Program. Two of our fastest growing customers right now here at PADT for Ansys usage, Rivian Automotive and Ursa Major Space, both started with PADT as part of our Ansys Startup Program. The program gives early stage companies access to the full suite of Ansys products with no limitations at a price they can afford. And if you join the startup program through PADT, you also get access to the business and technical expertise we can bring to the table. So if you're in a startup or you know someone in a startup in Texas, New Mexico, Colorado, Utah, Nevada, or California, and of course, Arizona, reach out. Let's talk and find the right package for you so you can drive your product innovation and virtual prototyping with the best simulation tools available. And yes, it is a violation of the license agreement for you to be using a university seat or your day job seat. It really is something you can afford. You can actually have access to the full Ansys suite. So reach out. We're here to help and here to get you to that next level. Okay, well, let's shift gears a little bit and talk about Q3 numbers and the Ansys stock price and the news and all that kind of stuff. So they put out their numbers since our last podcast for Q3. Revenue was $601.9 million. So that is up from $459 million for the same Q3 last year. That puts them at $1.66 billion year to date, which is up from $146 million. So, $200 million growth. That's pretty good for year to date. That's a 30% increase, in fact. So profit was also up. They had $128 million profit versus $55 million at this time last year for the quarter. And then year to date, profit was just shy of $300 million at $293 million. And this time last year, they were at 226, which is a 30% increase in profit. So good there. The number they really watch and seem to pay a lot of attention to is something called the annual account value. That's the value of all the leases and paid ups and maintenance contracts and things trailing 12 months. So that number is really, really important. It tells you how much people are buying. And that was at 541 for Q3, 541 million for Q3, and up from 458 since the last quarter, Q3 of last year. And then the year to date for 2024, so from January through October, was 1.5 million versus 1.4 million, which is a 9.2% growth in annual account value. So that's good to see. I find that fascinating because we're in the business of selling Ansys, but I always like to look at where the revenue is coming from. And so they released some of those numbers these are all numbers for the year through Q3. So 3 quarters worth of numbers. So 30% of the revenue comes from leases, 12.8 is paid up, and 53% is maintenance, with a little bit 3% for services. If you look at geography, 50% comes from the Americas, 23% for Europe, Middle East, and Africa, and then 6.7% of that European, Middle East, and Africa number just comes from Germany by itself. And then 26.3% was from Asia, with 8% in Japan, which is their biggest customer in Asia. So 73, also who's selling? 73% of the sales were direct, and 27% were brought in through channel partners like PADT. Looking at the balance sheet, which is really important to do, they're at $1.3 billion in cash, which is up from $860K at the beginning of the year. So they've got a nice increase in their cash reserves, and their long-term debt hasn't changed. It's at $754 million. I think it was $753 at the end of 2023. So the strong dollar is having an impact, and I tried to read it. I'll be honest, my eyes glazed over when I read that part of their press release, but you can check it out if that interests you. The dollar is very strong right now, so that's kind of an impact whether they're selling in the local currency or selling in U.S. dollar prices. So if you're following the stock and you care about these things, I do recommend you check that out. So if you want to do that and learn more and get more details and all the other numbers they release, and there's between general accepted accounting principles, which is what I report, versus the non-GAAP, which is what Wall Street cares about, check out investors.ansys.com. So every quarter's report is there with lots of detail, and I think a recording as well as their conference. So that's always good to do. So this gave the stock a nice bump, and it peaked at $355 right after the announcement, which back down now at $345. But as a reminder, Synopsys has offered to buy Ansys at $390, so it's still just kind of been flat. I mean, yes, it was a small perturbation, but overall, year to date, the stock is down 2.23% versus the S&P 500, which is up 26%. So, the price really doesn't have much to do with the how well the company's doing. It all has to do with that acquisition and perceptions around that. By the way, no new news there. Something to report on that. So Ansys did, they're quiet before they do their numbers, so they didn't put out a lot of news other than we did this great thing with this customer. One bit of press release that they did put out after they did their numbers was really cool. So Ansys has been working in the quantum space for quite some time, and people use Ansys tools to model kind of the multiphysics of a quantum computer, as well as the numerical tool suite in particular to model quantum impact, quantum effects. But photonics and things like that. But what they announced in this press release is they partnered with a company called IonQ. I assume that's how you pronounce it. It's not IonQ, but IonQ. And the company is a quantum computing company. They're building what they consider the next generation of quantum computers. And they'll continue to use Ansys tools to design that next generation of quantum computers. But also Ansys will work with them to see what simulation tasks, right? Quantum computers are good at certain things. They're really good at certain things. And so which of those tasks can they kind of offload or use to solve simulation problems? So they're going to work with them on that. So it's a partnership. It's not just they bought Ansys, I'm going to use Ansys, but they're going to actually also look at how Ansys might be able to run, or solvers of some kind might be able to run on their computers. So that's pretty cool stuff. I have read a couple articles that, most solvers in the simulation world are doing linear algebra, right? Solving matrices. It's actually pretty good at that. So it'll be kind of interesting. Maybe it's the probabilistic nature of it that they'll do for some of that stuff. I don't know, but pretty cool. And we'll keep our eye on things and keep you up to date as that progresses. We don't have any news here at PADT, so we'll just skip on to the Ansys blog. And as usual, I like to pick 3 articles that are worth sharing that people should read. And my 3 picks for this month of November are, the first one's called SiCame. I don't know if I'm pronouncing that right. SICAME. Maybe it's silicon. I don't know. SICAME? I don't know. Advances products, savings, and energy transitions with Ansys multiphysics simulation. So the reason why I like this is it's yet another, here's how a company's using Ansys, but what's really good about it is they're doing a lot of cool multiphysics stuff, fluid, thermal, structural type stuff. And so they really neat examples that I think most users of Ansys will find interesting. Then the next article I recommend is called Powering Ansys Mechanical Simulations, AMD versus Intel. Ding, 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 ding. So it's been a while. Ansys actually benchmarked the latest processors from both companies and updated all their tables. And I won't give away the winner and which one's better and where it's better, but you may want to check this out before you buy your next machine. There's some really cool The other thing I really liked about it is it shows how both AMD and Intel have increased the speed of their processors for solving Ansys, and how also Ansys has improved how their solvers run on this hardware. So some nice speed improvements in there. And so they got a graph showing the last 7 years from 2017 to 2024, how these things have sped up. And it's pretty cool. The other thing there's a little bit of an article on that I haven't really dug into too much is that AMD has a GPU called Instinct, and there's some information on that and how which Ansys solvers and how Ansys solvers run on that, so you don't have to just go with the one supplier of GPUs. So if you only read one Ansys blog article that I recommend for a while, I recommend you check this one out because it's really important that we know, even if you're solving in the cloud, you need to know which machine to pick to solve on. So that article was put out because Ansys had a big booth at Supercomputing 2024, and they did another article as well that kind of went over everything they talked about at Supercomputing 2024. It's called Empowering Innovation through HPC and AI-enabled simulation. So check it out. It goes over the HPC and the AI stuff that they shared at the conference. So it's kind of a summary of what they presented. So good stuff there. Over on the PADT blog, our people have been busy. Cynthia did another great article on optics. It basically goes over optics in Ansys 2024 R2. So what's new there, which is a lot. And then I put out an overview. If you weren't able to make our big open house I talked about in the last podcast, and it was also our 30th anniversary, we had over 500 people show up to PADT to see what we do here and talk about all sorts of cool things, including Ansys. It was our 30th anniversary. It was really great. So this article kind of gives you a summary of that with some pictures of all sorts of cool things that we did while we were here, including Engineering Jeopardy, which was a big hit in our PD lab. Then Josephine Holmes shared your essential guide to high temperature 3D printing materials, FDM versus P3 DLP. So these are two technologies that Stratasys uses. One is the extrusion technology you're probably most familiar with in 3D printings, and P3 DLP is a projector based photopolymer technology, and they each have their advantages and disadvantages. And she gave a really nice summary on how high temperature materials work in those two technologies and when you should use one or the other. And then lastly, since we last talked, Noah Asherbranner put out another great useful article about his area of expertise, or one of his many areas of expertise, called Model-Based System Engineering. And it's called Unlocking the Power of MBSE, SAM Bicycle Example. So SAM is the Ansys System Architecture Modeler. And so he did a bicycle using that tool, which is really good, kind of get your head around how you should be using these tools in Ansys to do system level modeling. And next section is upcoming events, which we don't have any, right? There's one tonight, which will be after this goes, or before this goes out. Actually, after this goes out. This will go after that event. Get my time right. I've been thinking about quantum computing, so it's all kind of meshed up in my head. But anyway, we have nothing scheduled for events with PADT through the end of the year. So we'll see everybody in January. I think the first event that we'll talk about for that is the big Arizona Optics or Arizona Photonics Days down in Tucson, which is always a big thing in Ansys. Hopefully, will be joining us at that. So we do have webinars scheduled through the end of the year. This one may come out before the podcast. It's called Optics Updates in Ansys 2024 R2, and we're going to talk about optics. Speos, Zemax, and Lumerical, which is why I'm thinking about the quantum stuff. That's going to be on the 14th, which is Thursday of this week. So even if you don't make it live, you can always listen to the recording by going to our website. And the next one's going to be Fluent Updates in Ansys 2024 R2. That's always popular. That's on the 27th. And again, you can watch the recording afterwards. And then the final one of the year is going to be our final structural update. Structural update number 3 in Ansys 2024 R2, where we're going to go over materials, contacts, and joints. And that's on December 11th, right? So that's it for news and events. I want to thank everybody, as always, for listening in. Do remember to subscribe to our newsletter at www.padtinc.com/opt-in. Do spread the word about the podcast. As the kids say, like and subscribe. It helps us in the rankings. And as always, never hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 132. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only, and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.